In this video, we want to talk about logistic regression, one of the most popular machine learning models step by step. In order to explain logistic regression, let's take this example. Suppose you want to predict whether a person buys a product or not based on his or her estimated salary. Review alert. In linear regression, we try to predict a continuous variable. And also, we try to fit a straight line to our data. But in logistic regression, we try to predict whether something is true or not. For example, these people have bought the product, but these people have not bought the product. In logistic regression, we try to fit an S-shaped curve instead of fitting a straight line. The possible values of this curve are between 0 and 1, and you can interpret them as the probability of buying the product based on the customer's estimated salary. So as you can see, if the estimated salary of a person is high, the probability of buying the product is also high. But if the estimated salary of a person is low, the probability of buying the product is also low. And if the estimated salary of a person is medium, the probability of buying the product would be medium as well. As a matter of fact, in this case, we are not that sure whether the person buys the product or not. So the probability is about 0.5. So we can use 0.5 as the threshold. And if the probability is greater than or equal to 0.5, we can predict that the person will buy the product. But if the probability is less than 0.5, we can predict that the person will not buy the product. And similar to linear regression, instead of one variable, we can have more complex models with more variables. For example, we can predict buying the product using estimated salary and age. Or we can predict buying the product using estimated salary, age, and gender, and so on. So you can see you can have different kinds of variables as well. But the question is how to find the best S-shaped line in logistic regression. Before answering the question, let's review something from linear regression. In linear regression, we try to fit a straight line, and we define residuals shown by the blue color in this figure. And we try to find the best line that minimizes these residuals. So this is how to find the best line in linear regression. But in logistic regression, we don't have the same concept of a residual, but we can use the maximum likelihood approach. Maximum likelihood by itself is a topic of another video. But in a nutshell, first you should pick an S-shaped line like the one you're seeing in this slide. Then you should calculate the likelihood or probability of seeing each data given this line. For example, the likelihood or probability of this data given this line is, for example, 0.17. And the likelihood or probability of this data given this line is, for example, 0.8. And you can calculate other likelihoods or probabilities given this line. And then you should multiply all these numbers. And if you do so, this would be the result. Now we can choose another S-shaped curve and calculate the likelihood values for this curve as well. And afterwards, multiply all these likelihoods together. And if you do so, this would be the result. You can try other S-shaped curves as well, but let's keep it simple and work with these two curves. Finally, you should choose the S-shaped line with the maximum likelihood. So in this example, we choose this line. Terminology alert. In this context, you should use the term likelihood instead of probability. But in previous slides, I used the term probability as well for those people not familiar with the topic. Also, we can check whether a variable is useful for prediction or not. Using a statistical test called Wald's test, we can test whether the effect of a variable on the prediction is significantly different from 0 or not. If the effect of a variable was not significantly different from 0, we could delete that variable to make our model more simple. I will do my best to talk about Wald's tests in future videos. So logistic regression can be used for classification, and it can use multiple variables of different kinds, discrete or continuous, to do classification. Also, we can test whether a variable is useful for prediction or not. So all of this cool stuff plus its simplicity makes logistic regression one of the most popular machine learning models. Now I really suggest you watch this video which is on the screen now.